All right, our next example is a survey of 245 dogs in a Missouri county showed 49 had been spayed or neutered. Construct a 99% confidence interval using these data. So we're going to define success. Remember, success is defined to be whatever it is you're looking for. So our success is dog has been spayed or neutered. I'm not really sure how the dogs feel about that, but anyway. Our sample size was 245, and we had number of successes was 49. From that, we can compute p hat, which is x over n, 49 over 245. Remember, the number of trials must be less, the number of successes must be less than number of trials. And so I have 49, I'm going to divide that by, 245, and I get that to be 0.20, right? Well, that should be easy enough. If that's p hat, q hat is 1 minus that. All right? And we need to have a 99% confidence interval. So we need to find z subscript alpha divided by 2. And I'll see if I can just hold this up here for us so we can see a close-up view of it, sort of. 99% confidence interval. And our value is 2.575. 2.575. And our formula is p hat plus or minus z alpha over 2 times the square root of p hat times q hat over n. And this is now plug and chug. So p hat was 0.20 plus or minus, we have 2.575. We have a large radical, we have 0.20, 0.80, and n we said was 245. And now it's time to start mashing buttons on the calculator. I have 0.20 plus or minus 2.575. And again, I'm going to be unapologetic with my rounding. I have 0.2 times 0.8 divided by 245. And then the square root of that number is 0.025 or 0.26. I'm going to round that to 0.026. If you get 0.025, if you get 0.027, 0.024, anything close to that is fine by me, right? If you get 0.138, you must have screwed up, did something wrong, go back and fix that. So if it's reasonably close to this, within a few values in this last decimal, that's, for our purposes, we'll consider that to be the same. And then I'm going to clear all the decimals out and just do this computation. Again, unapologetically, there is round off, maybe a little apologetically, but I'm going to compute with this with the round off error included. So this is 2.575. Multiply that by 0.026, and I have, again, I'm going to round this to 3 decimals, 0.06. I have 0.06695. I want to say that's 0.067. And so that is our value for the confidence interval.